When we're analyzing decisions in poker, it always comes down to two questions. How much equity do I need? And then how much equity do I have? Winning poker decisions are about analyzing your risk reward ratio, comparing that to your equity, and ensuring you have a positive expectation value. This math is the engine that runs winning poker decisions. Measuring expectation value in a cash game is very simple. The value of a chip always remains constant, and the chips we win are worth the same as the chips we lose. The expectation value of folding we consider zero to compare with other betting decisions, and the monetary impact of decisions are limited to the players that are involved in that hand. In tournament poker, this process is much more complex. The value of a chip changes throughout the event based on factors like the payout structure, the number of players remaining, and our chip stack compared to other opponents, our skill compared to other opponents, and more. Further, the EV of folding can be massive. We earn money by continuing to survive in the poker tournament and reaching those payouts. We can profit by staying on the sidelines and letting others fight each other to the death. In a tournament, the monetary impact of decisions are not limited to the players involved in the hand. The EV of decisions impact every other player in the tournament. And most importantly, the chips we win in a hand are worth less than the chips we lose. To understand this concept, let's take a look at an extreme example. There's 4 of us left in a tournament, and the prize structure pays 3 players. First, second, and third are all $1,000. 2 of the players have 10 chips. You and another opponent have 1,000. Now, the key here is to simply survive one more place. One person gets knocked out, and you make $1,000. So if you get involved at the hand of the player that has 10 chips, it's not very scary at all. However, if you get involved with the other player that has 1,000 chips, life is very scary. He can take all your chips and knock you out of the event. The term bubble factor is used to quantify how heavily the chips you lose are worth more than the chips you gain. Bubble factors tend to be around 1 to 4. A bubble factor of 1 plays just like a cash game where each chip has a constant value. A high bubble factor of 4 means the chips that you're losing are worth much, much more than the chips you're winning. When we're going to risk all of our chips, in order to compensate for a high bubble factor, the equity of our hand must increase. We'll use this visual as a fun example. Here's you, the poker player. You want to leap off this building. You want to survive. But as payout pressure, which is the bubble factor, increases, this jump gets more scary and more scary. In a bubble factor of 4, the jump might look something like this. In order to compensate, we need a net, a safety net, and our hand equity has to get higher and higher so that when we jump, we'll still be safe. So high bubble factors dictate premium holdings. In order to quantify the value of a chip in a tournament, a handful of models have been created. None of them is perfect. However, the poker industry has more or less settled on a model called the independent chip model, ICM for short. This model puts a value on our chips based on the probabilities of winning each position in the tournament. And we use this model to measure our decisions based on payout implications. There are many different ICM calculators you can use online to look at the value of different stacks. This brings us to the terms bubble factor and risk premium. Now, risk premium is another expression of the bubble factor. It's calculated by dividing the bubble factor by the bubble factor plus 1. So a bubble factor of 1.5 equates to 60%. And now to make this percentage useful, subtract 50% from it. 60% minus 50 is 10. So at a bubble factor of 1.5, we have a 10% risk premium. What this means is when we're going to go all in, we need 10% more equity than we'd normally need in that situation to have a plus EV betting decision. So in a cash game, if you're getting pot odds of 2 to 1, you need 33% equity to call. So let's say you have 40% equity. Well, you happily call. In a tournament, you're not done thinking. The first thing you need to consider is the risk premium. So if you're in a situation where you have a bubble factor of 1.5, and now you're getting 2 to 1, you now need 43% equity to call instead of the 33% equity that you'd need in a cash game. But since you only have 40% equity, now you have to fold. Now, risk premium also impacts your push-pull decisions. You'll learn about how to use your risk premium in your push decisions in the equity method program. Now, I want to clear up some misconceptions. ICM is the accepted method to measure the profitability of tournament poker decisions. It's the equivalent of EV of cash games. Players who disregard ICM are disregarding profitability in the event. It is true that players who make decisions based on chip EV and disregard payout implications do get first place more often. However, they pay a heavy price to do so. ICM is for those who wish to make money. If the glory of a first place is all you care about in a tournament, and you'll pay large amounts of money to get it, then by all means ignore payout implications. Payout implications impact every stage of the tournament. Certainly, it's more impactful around the bubble and the final table, but it's important in other stages of the event too. And finally, payout implications heavily impact your pushing ranges, not just your calling ranges. As I said, we'll teach you how to use risk premium in your pushing ranges during this program.